Hey everybody, this is Larry. This is day 11 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Yeah, today we have 1190 reverse substring between each pair of parentheses, so let's get to it. What was I going to say? I don't know that much to say. I just came back from running 7 miles of speed work. So I'm kind of tired, but I don't know. This week has just been very tiring for me, so we'll see how that goes. I'm trying to grind it out, and I did finish the workout today, so I'm happy about it and hitting all my paces. Probably a little bit faster than I should, and the reason why I kind of bring these things up is just that I think very often, just in general, I think people hide all the hard work that they do, and they just kind of show like, oh, I've always been, I don't know. I think there is some like inclination to be like, oh, I've always been, I'm smart or I'm fast, I'm whatever, but they just don't show the hard work. And I just think, man, it is tough. But also, there's no secret, I mean, I run about 50 miles a week now, give or take, maybe a little bit less on some weeks. But, so I mean, it's, if, and that's about like 7 to 8 hours of running. And, if you spend 7 to 8 hours, 7 to 8 hours on Leetcode every week, you'll probably be pretty good too at some point. So that's just as a point of reference. Though of course you have to make sure that you keep going and not get too tired. But yeah, all right, let's take a look. Okay, so you have some right? Okay. There are a couple of ways to think about this. I mean, n is 2000. It's a little bit so that you can what you can say what was I gonna say? 2000 means that you could do something n square, and it may be a little bit tight, but should be doable. The way that I want to think about this is just having stack things, right? I mean, I'm trying to think whether is it worth to kind of think out something that is clever in implementation, but I think in the worst case it's still yeah, because I think in the worst case it's still going to be I think in the worst case it's still going to be n squared probably. So it's just then in that case then you just think about what the simulation, not really a simulation, but just what that would look like. And yeah, but I think there is definitely a O of n time there, but I think I'm just trying to think whether is it worth to think through the complexity, right? But let me think. And for me, for now, it's just about honestly just about thinking through edge cases and whether or how hard it is. So for the idea behind a linear solution is just that if you have two of these, like love, like in example two, then you don't even need to flip them. But also every character you can just flip only once by doing it once at the end. So the n squared solution is if you have someone like this, let's say you have, I don't know, 4 of these, then you flip this 4 times, and then that becomes 4 times n, and if you have n parens, then it becomes n square-ish, roughly speaking. With like maybe n over 2 number of parentheses, or n over 4 number of parentheses, and n over 2 length in the middle, or something like this. It'll be n square, right? But of course, the key observation is noting that they cancel out. So then that allows you to do way less work. Of course, there's still some nuances there because, for example, you have something like this, then I guess this is a bad example, but maybe just here, then now you have to flip the inside one somehow so that it becomes like CPA love or something like this, right? So it's definitely doable, but it's just way, is that even right actually? I don't know, wait, hang on. Because then now, it becomes VOL, ABC, and then now this gets flipped 3 times, right? So then it becomes this. Actually, so I was right. That is actually a little wild, but yeah, so you can kind of think about doing stuff like this, right? But yeah, I'm trying to think. What would be the best way to kind of handle this? I mean, because oh yeah, just to be clear, right now I'm trying to do the n square. Oh, sorry, O of n solution, because I think O of n squared is pretty straightforward. Probably did it last time. Maybe I have a video on it. So I'm just trying to think about what's the best representation, right? I don't know that I know, to be honest. There's a lot of... Maybe I'm just also tired, to be honest, but... Like, we have to what would this even be, right? And of course you could have stuff in the beginning as well. The n square way is pretty straightforward. You just do it one at a time and you see it. Okay, so what does this mean? This means that this is 4 levels deep, so the end result is going to be this. This is 3 levels deep, that means that the result is just going to be this, right? And then this is 2 levels deep, so it should be this. And then this is 1 level deep, that means that it should be in the beginning, right? Is that true? Is this the right answer? Let's check it. I'm a little bit to check the intuition. This is what we have here, so I guess that's right. But of course, this is just if you know, they have something like this. But you can still have multiple things, right? So for example, yeah, like if you have let's say another one, then what would that look like? Well, you handle the level 4 ones first, and then now for the 3s you just do it in the reverse order. So is that right? I guess so. And then for the 2s, it's just the same order, and then 1, right? Is this right? I'm still trying to basically understand the invariance of this loop and whether I'm right with what I said. So I guess this is right. So in theory, then we can just do all the levels. We can just merge the levels together, I guess, in that way. Yeah, because I think the naive recursive way, right, would have been just like every time we see a left, and then when we see a matching parens, then we can recurse, right? So okay, so let me. I think I have a cute idea, but let's actually let's actually say that I lied for a second, and then just do the n square way, because then I think if I'm right, then I think you can actually build this from that, or that from this, and I think that's maybe a good way of doing it. So pause. Now we want left, right, inclusive, say. Right, and then maybe we want 0 and -1. So then now I mean, I'm trying to still be a little bit mindful of the space, right? So we have to, I think we have to do a pre-processing so that given left, given left, or maybe not even given left, but just given this set of things. Okay, so let's say I'm trying to think also, okay, maybe I should just test this, whether you can do something like this on the first level. Like, is that valid? Oops. Okay, so that is valid. Okay, so then now it'll go all of this, and of course we want to say maybe a for loop that parses them all together, right? So okay, so then now, but we have to be able to match them, and I think we can match them by just doing a thing, right? Pre-processing. So by using a stack. Okay, yeah. Okay, fine. So then for I in range of n, maybe just even IC in enumerate s. If c is equal to then stack dot append I, and then else if c is equal to then now we want to say right is equal to right, then now right lookup of top of the stack is equal to I and stack pop, right? So then now we basically find the matching in, well, we just pre-processing, and this of course is linear time, so that's just, instead of like doing another for loop maybe, right? And then now we have, okay, so for I in range of from left to right plus 1 because it's inclusive, if s sub I is equal to oops, the beginning, right? Then now we want to say words is equal to right? And then now we want to say we want to append parse left plus 1 right lookup of left minus 1 because that's where the paren is, right? And we want to reverse this, so let's just do it this, let's just do the reverse here. And then this isn't quite right because we now want to skip all this stuff, so we want to say or I is equal to left while I is and in here then now we increment it by, or we set it to right lookup of left, and then we also just increment by 1, so we skip the right lookup, right? And then we can return that join words. So this is the n square version. Pretty in theory straightforward, but apparently not. Key error 2. Oh, I, not left. I am confusing myself. Okay. Oh, of course. We don't have a base case. Okay, right. We increment. So else, if this should never happen, so we can maybe assert this. It shouldn't happen because we always skip it by having the left. So else, then words dot append s sub I. So this looks good. I'm just going to YOLO submit it. I mean, it's n squared. It should be okay, but you know, just want to you know, the first part of TDD is getting it correct, and actually went pretty fast, to be honest. I don't even know if we need to do linear time independent. I used Python 2 the first time, but yeah, okay. So I mean, this is fine, right? As we said, this is n squared, and actually pretty fast. I probably due to the Python string reversal is being pretty fast, but okay. But what we can do actually is we can say this is 0, this is depth, right? What can we say? So if depth is normal, so the key thing about this is that instead of I guess we can just reverse this. Why is that different? Is this good enough? Is this even right? Oops. Hi, premium. Okay, I mean this is wrong, but oh, it's because this is 0, and I guess the first one is no. That's not true. That's not right. This should be 0. This assumes that everything is in thing, but no, this should be 1. No, this should be 0. Why is the first one wrong? Right. Why is the first one wrong? So then there's what? This is 0. That was because I reversed it here. Instead of no, but this should have been reversed on the thing. Like this should be this thing, and then that would be depth 1, and that would be reversed, right? Oh, because I left in the reversal. That is just me being dumb. Okay. Yeah. All right, let's give it a submit real quick just to make sure it still works. And the funny thing is that this is why I kind of wrote it this way, is that just writing it this way, makes this O of n, which is why I kind of wanted to write it in n squared way to kind of illustrate the difference. And it's a very minor difference, and maybe I'm wrong. Let me know in the comments if I'm wrong, because like I was very wrong on Q4 on the contest, for example, and apparently that video is just crap. But the reason why, so okay, so let's actually have the other one up as well, just for comparison. Oops, what did I click on? So this is the n squared version, right? If it loads. This is the n squared version. The reason why this is n squared is because this can I do a reversal here on the return element, and that means that everything can reverse n times, right? Meaning, for example, like I said, you can have something that is, I don't know, something like this. I don't know how many things there is, 6 maybe, 5, 6. Right, but something like this, right? If you have something like this as the input, then it'll go to here. It reverses, reverse. So this reverse like n times, or as many times as you have depth, which can be O of n. Maybe not exactly n, but right. So this is n squared as a result, because this reversal move is very expensive and we do it many times. But here, the difference is, and I actually thought about writing this another way, because instead of just reversing, you can actually you can append things to the front. And the way to append things to the front is by using a deck, right? But I think this works too anyway. It's the same idea. But the reason why this is O of n instead of O of n squared, with this really minor change, is because this reverse only happens once per character. Right? Because everything else is just append and then we revert. Though I guess it's not quite right. It's not quite true because we're doing this join thing. So this join operation makes it n squared as well. So I think I'm lying a little bit here. I think I'm actually wrong on this just because of this join. What I want to write is maybe I mean, I think the idea is similar, but I think my implementation is a little bit off, mostly due to this join. Yeah. And I was just thinking about how to do this in a good way. So, okay. So, to be sure, the idea of this will lead to an O of n solution, but this is not it. The reason why this is not it is because we have this join, and because we have to do this join n times, and each time is O of n, this join is going to be n squared. So my first idea is just to, okay, well then don't join it except for at the end, right? So you would do something like this maybe. I don't know if this works because I don't know if reverse works, and append definitely. No, I mean that should work. Well, this doesn't really work, but let's want it just to see it'll give us, yeah. What we want is extend, right? What is it wrong on? Oh, it's wrong on this one. Why is that wrong? Do. Trying to understand why this code, what this code is doing. X, Y, Z should not be all the way in the back because it has two things. So why is this giving me that? Because it's depth 2. So depth 2, this means that there's no reversal, right? So okay, we can simplify this case a little bit just to kind of, well, just understand it. Because this should not be reversed twice. Okay. Why is that? So okay, so do 0. Is reverse incorrect? The 2 goes XYZ, 1 reverse. Oh, okay, that's why. Because okay, that is. I mean, that's a me mistake. Because what I thought that this would do is give me oh, because of this, yeah. Because what I want is that we want to reverse the order of the words, not the order of the characters. So that's where this thing is wrong, as a result of all the, or yeah, because we can't treat them as one character at a time anymore. Or why this thing is wrong, right? But I mean, so anyway, but this is still n squared even if this was right, and the reason is because of this extend. Extends copy everything by itself into the array, right? So what we actually want is, what I want anyway, is we actually want this to be an actual append, right? So that it appends the entire thing. And then now we can actually just reverse. Does this work? I mean, this doesn't work because this is now, we need to flatten this, but we can flatten it. So by flattening in one try, and having this reverse on the substrings, then we are able to reduce the requirements to of n. But oops. But the reason why it's a little bit annoying is because, I don't know, it's just annoying. Let's see. Right, okay, so this is a good representation of what we want, roughly speaking, right? So then now we just have to find it. I think that's, yeah. Yeah. But yeah, but the key thing is that this reverse function only happens once per character. And the reason why now, or the reason why this structure is different than the ones that we had before, I guess it's this solution. Even though this is the fake O of n, but it's n squared, but it's still close. The reason why this is different than here is that like this one is different than this one. The key difference is that we don't flatten by doing the join stuff, because in a way the join flattens each of them one step by step, and because you have to find it every level, you also have to reverse it on every level on each of the words that show up. Well, the reverse is not the expensive part in here, but the joining is, right? Yeah, the joining is O of n, so to get rid of the join, you have to do this thing. But why is reversal not expensive? Because this only happens once per quote-unquote, once per parentheses, right? Because keep in mind that words is maybe a confusing way to put it, but one word in my thing contains everything that's inside one parent except for single character cases, which okay, maybe that's a little bit awkward phrasing, but you can imagine that each word, for example, encompasses each one parent, right? And because of that means that per parent we're only reversing once, and also I guess once for each character in the case of here, right? So this reverse only does once, and you can think, and the way that I wrote this is honestly a little bit lazy, because I know the math and it works. But another way to think about it is, okay, let's actually do a deck now, right? Then now, here, if you think about it, then here, maybe if dep mod 2 is equal to 1, then we want to reverse, or another way to reverse is just append left, or append to the front. And of course, this looks much more uglier, but the idea is the same, right? So then now if dep It's just that we're doing it once at the end instead of once in the beginning, right? Or once as we do it, and then now we don't need this anymore, right? So this will give us, roughly speaking, the same thing, except we have decks, of course, instead of lists. But yeah. But I think with this now it becomes more clear why this is O of n, right? Because now we don't have the reverse thing anymore, and all of these are O of 1, and each character will only append this, at one time. The only thing that's a little bit awkward right now is that now we have this structure and we need to flatten it because we have multiple layers. And the reason why we kept the multiple layers is so that we can keep this as O of n. Right, because before we reverse as we get it, but now we add stuff to the beginning instead, and we don't compress it, because if we compress it, then, or at least the way that I did it with the compression recursively, is that we keep on compressing character by character, and as a result, especially with the reversal, it becomes n squared, which is what happened here with the join, right? But now, but now we can just find it. And how do I even find it? Well, I'm trying to be really careful to make sure that I don't want to. Here is the space where I make it n squared. That would be a little bit silly. But no, I mean, I think we can do this. Maybe I won't do it this way. Maybe I'm a little bit lazy, so I'm just going to write it like this. Right, and then here, maybe we have current, right? Then while length of current is greater than 0, because we have decks, it's a little bit. I mean, while we have decks, we might as well use them. So then we have current.pop left, right? So, right? Then if now is a deck. Because it's either a deck or is a character, right? That's just how we have it. I always forget how to do it. Python type of, because it's not something that you should use very often. But just type, right? No, it's like is type. I think is is it, or am I just thinking language? Mixing up languages. Is instance, okay. Okay, let's try it. Is instance now of then now we find now, right? So this is just recursion, right? Else, if it's not a deck, then we just append. Well, we just append now, right? And that's pretty much it. And then after we flatten words, we can now return, finally join it only once. Yeah. And there you go. Let's give it a quick submit. All right. I mean, it's a little bit slower because of a lot of overhead. I guess the inputs are not very whatever. But this is O of n. So that's how I have it, and yeah, it's I don't know. Is it worth it? Let me know in the comments whether you think it's worth it to kind of do this O of n. I end up spending a lot of time, but I think this is a very good learning experience, right? Because as you can see, even here, at first I was like, oh, this is here I was like, oh, we thought we can write it in O of n, but I wanted to set up this structure because I knew that here I mean, I already knew this before writing this, but I just want to get something correct. But also, I recognize that you can also come up with the other way where you have this, and you recognize that you're repeatedly doing this reversal. So how do we get rid of it, right? And the way to get rid of it is by having this step thing, which you have to really think through to kind of understand how it worked. But after that, then you're like, oh wait, the join thing is finding every time, which yeah, which is expensive, that's all, if nothing else. So then now you want to just find it once for a character, and that's basically how we got to here to O of n. So this is linear time, linear space. This is how I do the matching up. This is how I recursive parsing, right? And here is finding the results we got from this structure. And yeah, this is a long one. I am tired. I need to, I don't know, do anything else. So that's all I have for this one. Let me know what you think. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know if you learned anything from this one, because I know I took a little bit of a long time, but it was to explore all the other ideas. And yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.